So next up, we're going to talk about another area where technology is moving really fast, and it's challenging the way we design and test really complex systems, and in particular, necessitating the use of modeling integrated very tightly with real-world data. And that's the area of radar systems. So to help educate us on this challenge, we have a privilege to have a real expert on this from the U.S. Department of Defense. So please welcome AFRL Senior Advisor to Air Force Futures, Dr. Howard Meyer. Dr. Meyer, there he is. Yeah. So, Dr. Meyer, tell us about the challenges you're focused on at the Pentagon.
Okay, thank you very much. Good morning, and I want to express a sincere thanks to our host, NI, and also to you, Eric, for inviting me to participate in what is surely to be a great NI Connect event. I have the extreme privilege of serving as the Air Force Research Laboratory Senior Advisor to Air Force Futures, the headquarters U.S. Air Force organization responsible for developing the requirements and the force constructs for our nation's Air Force of the future. In saying this, I have to admit that representing an organization that employs over 11,000 people with a budget of over $7 billion is a significant challenge, but I'm enjoying it immensely. As a nation, we can no longer afford to spend decades developing the military capabilities that we need, both now and in the future. To significantly accelerate the development of these capabilities, digital engineering has become an essential. Digital engineering works. It's demonstrated great success at dramatically reducing both the time and the costs associated with developing new weapon systems, such as the Air Force's Next Generation Bomber and Next Generation Air Dominance Fighter. By employing the latest high-fidelity, physics-based modeling and simulation tools for aerodynamics and mission-essential systems, coupled with integrated CAD/CAM capabilities, digital engineering ensured that when prototypes were developed and fabricated, they performed as expected. Personally, I have a high interest in the electromagnetic spectrum. All military systems rely on RF and electro-optical sensors and communication systems. If we can't see to sense the operational space, and if we can't communicate to direct the actions of our forces, we've already lost. For these reasons, our communication systems must be significantly more robust and resilient. And our sensor systems must be capable of detecting and tracking fixed and moving targets at greater ranges, in all weather, in all operational environments and conditions, and including even when our adversaries employ deception against us. The complexity of the future electromagnetic spectrum battle space is going to increase significantly. The amount of useful RF spectrum will continue to decrease as all parties, friendly, adversary, and neutral, employ RF technologies for all reasons. Concurrently, the global proliferation of advanced electronics technologies is enabling our adversaries to develop and more effectively tools and more effectively contest our use of the electromagnetic spectrum battle space by hindering and denying our ability to see and communicate, and thus effectively employ our forces. This means that future military EMS systems will require enabling technologies and architectures, and also commensurate test and evaluation capabilities to ensure the systems we're developing perform as advertised. Recall what I said about digital twins, and let's apply that to the EMS battle space. We must be able to instantiate operationally realistic digital twins into increasingly complex and realistic EMS environments to accelerate the development of the military capabilities that we need. We need this much because much of this work is either too costly or it's very, very difficult to impossible to replicate in open-air test ranges. Now, this brings me to a digital engineering environment, really a success story that was developed specifically for the Air Force for RF applications, including radar and electromagnetic warfare. RFView. Developed by Information Systems Laboratory with funding from AFRL under the Small Business Innovation Research Program, RFView enables digital twinning of any advanced RF system operating anywhere in the world under whatever operational conditions we require. Of equal importance, we need the ability to develop to employ real-time flight hardware and hardware in the loop interfaces in these virtual environments. And ISL did this for us with RFU using NI transceiver technology. All of this means that we need you, each of you present today and listening, the developers of these remarkable technologies that our nation is so critically reliant upon. We need you to continue their advancement so we, the Air Force and the Department of Defense, can continue to develop, explore, test, and validate the EMS capabilities our nation needs to ensure all people everywhere can continue to enjoy the freedoms we all treasure. Thank you, Eric, for inviting me and giving me this opportunity to share these needs. And I want to thank each one of you, the developers of these truly amazing technologies, for listening to me today. Your work is difficult and challenging, but it's essential.
Dr. Meyer, thank you so much. Appreciate it.
Thank you very much. It's an opportunity.
All right, thank you. Thank you.